Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Sun Simulators and the End of Photosynthesis. Now, the evidence that sun simulators are being used to illuminate the Earth's atmosphere is overwhelming. The sun we see in our sky seems to be of two types, a physical light source and a holographic projection. The physical light sources are the result of physical devices or sun simulators using laser-based technology. Holographic projections would be the result of holographic projecting devices, which are also based on laser technology. And it is possible that the same devices are creating both types of sun simulations, but that in one instance the device is providing direct illumination, and in the second the device is projecting the light at a certain distance away from it. And here you see some examples of sun simulators, and these are being direct sources of the light, and you can also see the laser beams coming from these objects. And there's a green laser beam from this one, there's a pink laser beam going through that one. So, and you may look at article 214 for more details on this. And here is an example of a holographic projection of the sun, which seems to be within cloud. And this is as seen from an airplane, so from above. And it's possible that both the clouds and the actual light source inside it are both holographic projections. And you may look at article 233 entitled The Holographic Sun in the Clouds. And here's another example of a holographic projection of the sun. And here we see an airplane that actually flies right through it. And of course, it's not the real sun because it's in the atmosphere. And a real plane would never fly through, a plane would never fly through the real sun. So we know this is a holographic projection. You may look at article 388 entitled The Sun is No Longer Shining, Sun Simulators Replace the Sun. The evidence is therefore quite conclusive that sun simulators are being used. The reason for the use is the fact that the sun is now a dark star, and I've written about that in other articles, and you may look at article 453 entitled The Sun is Now a Dark Star for more details. In other words, the sun is not emitting light, at least not visible light, and not anything more energetic than visible light. It may still be emitting some infrared light. But upon hearing about simulators having replaced the real sun, many people ask themselves, how is that possible? Where is the power coming from, and how do plants continue to be able to have photosynthesis? Well, the power generation problem was solved by 1972, the invention of a laser fusion reactor. And you may look at article 407 entitled Sun Simulation System, Technology and Power Generation for more details. Lasers emit radiation. Visible light lasers will emit red, green, and blue light, which together will make up white light. Ultraviolet light lasers also are being used and will boost the amount of heat transferred to the Earth's atmosphere through the radiation emitted by the simulators. In order to also keep the heat in the atmosphere, metallic aerosols are sprayed in the atmosphere in order to create an artificial greenhouse layer. And you may look at article 461 entitled How Do the Sun Simulators Heat the Atmosphere in the Absence of Solar Radiation? And then photosynthesis occurs as a result of no longer the sun emitting light, but the sun simulators emitting that light. But photosynthesis uses visible light radiation to transform carbon dioxide and water into sugar and oxygen, as illustrated here. So photosynthesis is basically the transformation of light energy into chemical energy, which a plant stores. Plants have pigments which absorb visible light and use the absorbed energy to transform carbon dioxide and water into simple sugars. In other words, well, mainly glucose and oxygen. The main pigment used by plants to do this is chlorophyll A, and this pigment absorbs blue and red light. The other major pigment used by all plants is chlorophyll B, which also absorbs blue and red light, but plants usually only have the amount of chlorophyll B in comparison with chlorophyll A. Plants also have other accessory pigments, but they occur in much smaller quantities than chlorophyll, and one of the most common is beta-carotene, which absorbs blue light and a little green light. And you can see here where these pigments absorb, where the peaks are is the wavelength at which they absorb light. And chlorophyll A is the main one, and it absorbs high energy blue light. You can see it's the peak is close to the purple. This is higher energy is towards the zero of the axis here, so close to 400 nanometers. So chlorophyll A absorbs blue light and absorbs red light. So this is the red part of the spectrum. And it doesn't absorb any green light, or maybe a tiny amount, but very, very little. And it absorbs more blue than red. And then chlorophyll B also absorbs blue light, but the peak now moves a little further down towards 500 nanometers, so it's lower energy blue light. And it absorbs higher energy red light, because it's moving towards the 600 nanometer marker, but much less than blue light. So as you can see, chlorophyll basically absorbs blue and red. It doesn't absorb green. In other words, the green light is reflected by the leaves, which is why leaves look green. And then the carotenoids, the main one being beta-carotene, absorbs blue. You can see this. One of the peaks is in the blue range, and the other one, it touches a little bit goes a little bit into the green, but very little. It's mainly blue. So plants look green because the pigments in the leaves do not absorb, i.e. they reflect green light. Plants use mostly blue light for photosynthesis. Red light is however used to manufacture substances that promote growth. So basically, if the simulators emit blue and red light at an adequate intensity, then plants will continue to grow. This means that if the atmosphere looks bright enough to us, then plants will be able to continue to have photosynthesis. Photosynthesis reaches a maximum at a maximum luminance of about 50,000 lux. And lux is a measure of luminance, or the brightness of light as detected by the human eye. This maximum luminance value translates into a light intensity of 73.2 watts per meter squared if the light has a wavelength of 555 nanometers, which is the wavelength to which the human eye is most sensitive to. But light does not have to be nearly this intense for photosynthesis to occur. Light intensity can be translated into a certain number of electrons emitted per second per surface area. However, that number is usually huge. For example, the number of photons emitted by a 100-watt light bulb is about 10 to the 40, one followed by 40 zeros per second. Photons are thus a fluid, or light is a fluid, which is why they have a wave nature. And you may look at article 438 entitled Planet X reveals that a light wave is a photon fluid. But as the amount of stellar core dust keeps increasing in the Earth's atmosphere, because more and more stellar cores will most likely keep arriving, the simulators will need to keep emitting more light to keep up with the absorption. And if they are not able to keep up with the absorption, the atmosphere will become completely dark or red. Even with no visible light, which will make the atmosphere dark to us, the Earth will continue to emit infrared radiation, which the stellar core dust will absorb. But photosynthesis would then stop and plant life would die, followed by animal life. Humans would then only be able to survive in sealed environments, which would keep the stellar core dust out. However, stellar cores would continue to break up the Earth's surface and cause earthquakes. So even underground cities would be in danger of being destroyed eventually. So in conclusion, sun simulators are at the moment managing to keep the atmosphere illuminated to the point that photosynthesis continues to occur. It is however possible that as the planet X or stellar core dust continues to increase, that the sun simulators will eventually not be able to keep up, and the atmosphere will become dark even with the simulators, so that photosynthesis will become impossible. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.